G'day guys. Alright, so today we are starting a new topic. The topic is called univariate data. Now I should mention that next term we study another topic called bivariate data. Alright, now together these two topics form statistics, split into two parts, and that's how we do it. Now what's the difference between the two? Well, univariate means one variable, okay? So an example of some univariate data would be let's just say I write down a list of, let's just say I write down the temperature of every single capital city in the world on a list. Okay, that would be about 240 numbers in degrees Celsius in one variable, temperature. That's an example of a set of univariate data. All right, well, what about bivariate data? What's an example of that? Well, let's say I have a classroom of, say, 20 people, and I get all 20 of those people to measure two things, their stride length and their height. Now that is two variables. Then I could construct a table of values and fill it in. I would have row headings, stride length and height, all right? And I would fill that in with all the numbers that I had generated from the class. And I would see that there is a relationship between how long your stride length is and how tall you are. So bivariate data deals with the relationship between two variables. So it's a more sophisticated sort of statistics. Univariate data, which is this entire topic that we're doing right now, deals with data in one variable. All right. So good to set that straight right from the beginning. Having said that, let's dive right into the first exercise, which is 2A. And today we're just learning about different types of data. So we're classifying data, really. All right, so we have a bit of a tree diagram going on here. Data up the top, which branches off into two major types, numerical data and categorical data. Let's deal with numerical data first. Now, numerical data is exactly what it sounds like. It is data represented by numbers. For example, I write down a list of the ages of every student in my classroom. That would be an example of numerical data. Nice and simple. Okay, what about categorical data? Well, categorical data is basically everything else. So data represented by anything other than numbers. For example, I could ask all the students in my classroom to write down their favorite color, and I would just have a list of colors: blue, green, yellow, yellow, green, blue, green, yellow, yellow, blue, etc. You get the idea. Now, they're not numbers, they are words, so that is categorical data. Now, occasionally, there can be some confusion because sometimes numbers can be used more as symbols than as things that count stuff. And in those unique situations, sometimes data that looks like it might be numerical data is actually categorical data. Or sometimes it can just be considered both. So there is a little bit of overlap between the two. But broadly speaking, numerical data is numbers and categorical data is categories of things. Favorite color, eye color, favorite kind of ice cream, that sort of thing. All right, now this tree diagram branches off even further. So we have two types of numerical data and we have two types of categorical data. So let's look at our two types of numerical data first. All right, so we have discrete numerical data and continuous numerical data. Now, discrete numerical data, right here, that is data that can be counted. For example, the number of students in a class, you can count that. It's either 1, 2, 3, 4, 5, 6, 7, etc. Okay. Now that might seem obvious. You might think, well, surely you can count every sort of numerical data. That's what numbers are, counting things. Well, let me explain what continuous data is first, and then we'll go back to that idea of discrete data. All right, so what is continuous data? Well, that's numerical data that cannot be counted due to its continuity. For example, the height of a person. Now let's think about this. Can you count the height of a person as a variable? Well, no, because you might find someone who's 180 centimeters tall, and then you might find someone who's 181 centimeters tall, but it's always possible to find someone who is 180.5 centimeters tall, who splits the difference. And then it's always possible to find someone who is between 180 and 180.5 centimeters tall, so 180.125. In fact, it's possible to find someone who's 180.000000001 centimeters tall. So there are infinitely many height values, okay? Which means it's not a countable variable, it's continuous. So that is the difference. Now, if we go back to the idea of discrete data for a moment, now you might understand a bit better what I was talking about, because the number of students in a class is discrete data because they can be counted. You cannot have 2.37 students unless we're talking something really gruesome involving a giant chainsaw or something. Okay, so there's the difference. Discrete data is data that can be counted. Numerical data, continuous data is numerical data that cannot be counted due to its continuity, and height is a good example of that. All right, now over to categorical data. So we have two types of categorical data, nominal and ordinal, okay? Okay, so here we go. Now, nominal data, nominal categorical data, is data that cannot be ordered in any way that makes sort of mathematical sense. For example, favorite type of ice cream. I'll use that example again, okay? If I asked 20 students to write down their favorite type of ice cream, I would just have a list of 20 words: strawberry, boysenberry, chocolate, strawberry, etc. So that is nominal categorical data. There is no order that you can put those words into that makes sense in mathematics. All right, now what about ordinal categorical data? Well, that's data that's categorical, okay? It's not numerical, it's categorical, but it can still be ordered in a meaningful way. So let's think of an example. Here's one. All right, for example, the answer generated by a survey that asks you to tick either, and then there will be a few boxes in a row for you to tick. Bad, average, good, great, excellent. Now these are categories, okay, and it's data, and there is an order to it, because bad obviously goes before average, average goes before good, good is less than great, so it goes before great, and then great is not as good as excellent, so it goes before excellent, and so on. So there is a logical order to those categories, even though it's not numerical. Now, students tend to find these four subcategories really confusing. And to be honest, so do teachers. And quite often when you're confused, you're confused because you look in the answers to the textbook and it says it's ordinal when it should be nominal, or the other way around. And quite often I might actually agree with your answer as opposed to the textbook's answer, because there's so much overlap between these. But hopefully I've given you enough there for you to have a broad understanding of the differences between those four. All right, now because nominal and ordinal, the two types of categorical data, are the ones that people tend to get a little bit confused by, I've got a little activity down here that I'm just going to run through with you. It ignores numerical data. That one's a little easier. And we're just going to talk this through, this practice question right here. All right, so colour, and obviously I've already done the colouring, but colour the nominal variables green and the ordinal variables red. And then we have a list of 6 variables, okay? So remember, the nominal categorical variables cannot be put into any kind of meaningful order, whereas the ordinal categorical variables can. All right, so birth date. Well, that's going to be an ordinal variable because although it's categorical, okay, there is an order, isn't there? The 7th of May comes before the 8th of May. So there is an order built into those categories. So that's birth date is an ordinal variable. Favourite sport? Well, if you ask 10 people to write down their favourite sport, you can't say that tennis comes before cricket in any kind of meaningful mathematical way like we did for birth date. So that's a nominal variable. Year level. So year 7, year 8, year 9, year 10. Obviously they can be ordered. So that's an ordinal variable. Travel method to school. Once again, if I got 5 people to write down how they get to school, that list might look something like this. Car, bike, car, bus. There is no meaningful mathematical way to order those responses. So that's an example of a nominal variable, travel method to school. Favourite type of music, exactly the same thing. And this is an interesting one. Restaurant rating out of 5 stars. So the options would be 1 star, 2 stars, 3 stars, 4 stars, 5 stars. That's obviously ordinal, isn't it? Because 1 star is worse than 2 stars, which is worse than 3 stars, and so on. All right, guys, if you found that a little bit confusing, don't worry too much. Everyone always finds classifying data confusing. And to be honest, sometimes even the people that write the textbook get confused and write answers in the back of the book that aren't what I would consider to be, or any other teacher would consider to be, the right answer. So it's a little confusing. Hopefully, though, that was enough for you to get the gist of it. Have fun doing the exercise, and I'll see you next time.